These notes are going to show you the different multiple ways to represent things that are dealing with functions, because our next unit is going to deal more specifically with types of functions and things that we can do with them. The 4 ways of representations are through the table, the ordered pair, the graph on the coordinate plane, and a thing called mapping. Mapping is going to be newer to many of you unless you've had experience in an algebra classroom before. It's very easy and similar to the table, right? But it is a different take and a different look on things, right? So I'm going to work out some of these examples with you as examples, and then what I don't do with you, you're responsible for on your own going back and completing the rest of this page. All right, so we're going to start off with number 1. They gave you the mapping, and it doesn't always have to be rectangles. Usually it's ovals, but it'll always have arrows connecting an input value to an output value, right? Please recognize that in tables you are going to have your XY columns, and remember that the X refers to the in and the Y refers to the out. And then with ordered pairs, you always want to write it with parentheses, the X value first, followed by a comma, then the Y value, and close your parentheses. Without parentheses, you have not written an ordered pair, and it will be marked off. Then the graph is just plotting the points on the coordinate plane without connecting them. We are just simply plotting them. Okay, so taking the mapping that is given, we want to turn them into ordered pairs first, because that's usually the easiest thing to start with. So if I have an input of 1, that's my X value, and then my output of 1 is my Y value. So there's my first ordered pair. Okay. In the second one, I have an input of 2, and that corresponds to an output of 5. I keep reading it, and I have an input of 3 that has an output of 9. And then when I go to my input of 4, it also has an output of 9. You can have multiple inputs and outputs shared with each other, right? And that's usually where the arrows point to the same number or come from the same number and go to other numbers. Okay? The only thing that needs to be there, because this is a set of ordered pairs, it is held together with the fancy braces on the outside, and that formally tells you that all of those ordered pairs are in a set. Okay, usually from the ordered pairs, the graph is the next best thing to do. Okay, this graph does count by 2s, and you'll have to just be careful because the grids are very tiny. Right, but we're going to do the best we can and get the closest to the right spot that we can. All right, so for +1, +1, you're going to start at the origin. You're going to go right 1 and up 1, and you're going to put your dot. Right, for 2, 5, you're going to go right 2 and up 5, and put your dot. Okay, for 3, 9, you're going to go right 3 and up 9. And for 4, 9, you go right 4 and up 9. So those 2 dots should be side by side horizontally to each other. There is no need to connect them. It is just 4 random points. Okay, then if you go over to the table, you can take those ordered pairs and very quickly fill them in. So you have 1, 1, 2, 5, 3, 9, and 4, 9. Now this table does have an extra row. You don't need to worry about that. You can actually just cross through it. Right? It's there in case you need that 5th value, because there are some tables, as you can see in number 2, where the whole table is filled in. So if you ever don't use the whole table, right, it doesn't mean that something's wrong. It just means that the table is a standard table and you just cross off what you don't need. Okay. The next problem I'm going to work out for you as an example is number 3. Notice that they start us with the graphing, and then we must fill in the other 3 ways of representing. Right? So from a graph, the easiest thing to do is always to get your ordered pairs. Right? And with this one, you do have to be very careful because, like I said, this graph or grid is very tiny, and it is sometimes hard to read the ordered pairs. So just do the very best you can with it, and as long as your numbers look similar to where they should be, you'll have no problems. The graphs that we do in class will be much clearer and much bigger. Right, so if I want to start with the lowermost dot on the left, that means I'm going left 7 and down 3, so that's represented by -7, -3. Okay, and then if I go to the next dot going from left to right, if I go left 3 and up to 5, then I'm going to have -3, 5. Okay. And again, it doesn't matter what order you put these order pairs in, as long as you've got all 4 of them. Since there are 4 points, then we're going to have 4 dots. Okay. And then if you go to the right of it, we're going to go right 3 and up 5. So +3, +5. And then for the 4th dot, we're going to go right, looks to be about 7 and up 7. Some of you might think that that's an 8, but again, it'll be more clear when you actually get the grid. Okay, so we're going to call it 7, 7. And again, make sure that you put your fancy braces to hold that set of ordered pairs together. Okay, now that we have the ordered pairs made, we can go ahead and fill in our table. Right, so we have -7, -3, -3, +5, +3, +5, and 7, 7. And again, that bottom row is just not used. Okay, then we go over to the mapping, and the mapping must always have the two sides, which you can use ovals or you can use rectangles, it's up to you. Okay, but it also must have the labels in and out at the top. Okay, and another word for in that you're going to get familiar with over the course of the next few days is the word domain, and the word range, it would be your out. So these are synonyms to each other in this chapter. Right, so you want to list all of your domains, but you cannot repeat numbers. So if a number repeats, you only list it once. So in our mapping, we're going to have -7, -3, +3, and 5. In our range, or in our outside, we're going to have -3, +5, and 7. You're not going to write that second 5 because more arrows are going to point to it. Right, so here's what the mapping would look like. You start at -7 and you draw your arrow to -3. Okay, then the next order pair is -3, 5. So start at -3 and you go to 5. Next is +3, +5. So you start at +3 and again go up to 5. So 5 will have 2 arrows pointing at it. Oops. And this should say a 7 down here on the input side. That was my mistake. Okay, so we're going to go ahead and fix that real quick. Hopefully some of you caught that before I did. So there's a 7 down here. Okay, and now we're going to take that 7 and connect it to the 7. So that's what your completed mapping should look like. Right? It's taking that table and turning it into inputs and outputs where you have arrows going to it. For the last example I'm going to do with you, we're going to jump down to where, in this case, they gave you the 4 representations, but they gave you an equation as your starting off piece, which means you have to use the equation to fill in the table, to make your order pairs, to make your graph, and then create your mapping. So it really does need to go in this order. And as far as the equation goes, it's already set up the way it needs to be, and your table has already provided you with the inputs that you have to use. Right? So the way this works is they're giving you the x value, so in the equation you replace the letter x with the number they gave you. So for instance, if I put the 2 in, I'm taking 7 minus the absolute value of 2. The absolute value of 2 is 2, so 7 minus 2 makes 5 come out. Right? Then the next one, you would replace the x with the 1, so 7 minus the absolute value of 1. Absolute value of 1 is 1, so 7 minus 1 is 6. Then you're going to do the same thing, 7 minus absolute value of 0. Absolute value of 0 is 0. 7 minus 0 is 7. Okay? Then you want to be careful with this next part because the negative numbers can mess people up. You have 7 minus the absolute value of -1. Absolute value of -1 is still +1, so 7 minus 1 is going to give you 6 again. And then do the same thing, 7 minus absolute value of -2. Absolute value of -2 is 2. 7 minus 2 is going to give you 5. So you can see that you have 2 values on the y side that are being used twice. Okay, so now we're going to go ahead and write our ordered pairs from this. You have an x, you have a y, you make it an ordered pair. So open up your fancy braces, and then we put them in order pair status. 2, 5, 1, 6, 0, 7, -1, 6, -2, 5. Okay, and close your braces. Right, so you should have 5 ordered pairs because there were 5 values in the table. So when we go to graph, we should have 5 points on our graph. Right, so for 2, 5, it's right 2 and up 5. So there's that one. Right 1, up 6. There's that one. 0, straight up to 7. There he is. -1, 6 is left 1, up 6. So now we're going to come back downhill a little bit. And then -2, +5. Right. Now, because this is an actual equation, right, we do want to connect the dots. Right? With equations, it does get connected, and we do put arrows at the end to show that this would continue on if we had more values for x that we needed to plug in. Right? So you might want to put a little note up here to yourself that you want to connect the points in equations. Okay, so now you have your picture taken, and we wanted to take and make the mapping, which is your inputs and outputs. So you want to set up your left side with the word in, your right side with the word out. Okay. The input values are exactly like the table, nothing repeated, so it's 2, 1, 0, -1, and -2. Right? But your outputs did have some repeaters. You have the numbers 5, 6, and 7. You don't need the 6 and the 5 again because it's already there. Right? And now you're going to draw your arrows. Right? You'll notice I'm not going to draw ovals or squares or rectangles around this. You can just simply label them as I'm doing here and just draw your arrows, and it's still considered mapping. Right? So we want to take the 2 to the 5. We want the 1 to go with the 6. We want the 0 to go with the 7. We want the -1 to also go to the 6, and we want the -2 to always go with the 5, right? So there is some overlapping, which is fine, right? But everything is pointed to its proper output given its input. Right, so the remainder of these problems, the other 3, are yours to try, and we will check those in class together now that you've seen the examples and the categories and the different ways to represent a function.